Section 4.10 Nonlinear differential equations. In this section, we are going to solve the nonlinear differential equations using the reduction of order technique. The solution of differential equation is the function y as y the function of the x. That means x is the independent variable, y is a dependent variable. So we will see case 1 and case 2, where case 1, the dependent variable y is missing, and case 2, the independent variable x is missing. Both of them, we're going to start with the same process by substituting y prime with the u, or the y prime divided by dx as the term u. And then next, we're going to replace y double prime in the terms of the u, depends on the case 1 or case 2. For case 1, the dependent variable missing, or the y is missing, the expression in the equation will have x, y prime, and y double prime. To use the order of reduction, that means we're going to reduce the order 2 down to order 1, starting with u equals y prime, or u equals dy by dx, and we're going to remain x as the independent variable, but we reduce the order of the y from y prime, y double prime into the u and u prime term. Therefore, the u prime, or the u by dx, is the same as y double prime. And then the new equation will become the form of the x, u, and u prime. Then you will see the equation becomes a separable of variables. We solve this differential equation and solve for u, and then integrate one more round to get the solution y. From the process, you will see there are two constants of integration appeared after you are done. The first example, we have y double prime, we have x, we have y prime, and as you see, no y or no dependent variable. Let u be y prime, which is dy by dx. As x still in there, so we keep x as the independent variable. So the u prime is the same as du by dx, which is the same as d by dx of dy by dx, or the second derivative of the y with respect to x, or we just say it's the same as y double prime. It is the direct substitution as u equals y prime, u prime equals y double prime. Then replace into the equation, y double prime now is replaced with the u prime. 2x equals 2x multiplied by y prime, which is the u, to the power second, as u prime in the form of du by dx. Use a separate variable technique to solve for u. Then we get 1 over u squared equal du equals 2x dx. For the antiderivative, both sides, we have negative 1 over u equals x squared plus the first constant of integration. And since u is y prime, or the dy by dx, we place it into the equation to have negative 1 over y prime equals x squared plus c1, or y prime equals negative 1 over the quantity x squared plus c1. Next, we're going to solve for y by finding the antiderivative of negative 1 over x squared plus c1 with respect to x. Therefore, the y is negative 1 over square root of c1, the inverse tangent of the x over square root c1, plus another constant of integration c2 as a general solution of this nonlinear equation. Next example, in the equation, we have y double prime, we have x, we have y prime. As we make a list, x, y prime, y double prime, involving into the equation, but no y, or no dependent variable. Use the substitution as before, so u as a y prime, and u prime, or the du dx, is the same as y double prime. The new equation will be involving x, u, and u prime for this time. So y double prime is u prime. And x multiplied by y prime, which is u squared, equals 0, with the initial condition y at 1 equals 4, y prime at 1 equals 2. And this case separate completely, so we have u prime equals negative x u squared, or 1 over u squared du equals negative x dx. Antiderivative both sides have negative 1 over u on the left equals negative x squared over 2 on the right plus the first constant of integration. With the initial condition y prime at 1 equals 2, which is the same as u at 1 equals 2, excuse me. So replace it to find C1. So then we get negative 1 over 2 equals negative 1 squared over 2 plus C1, or C1 equals 0. That leaves us 1 over u equals x squared over 2, or u equals 2 over x squared, y the u is the y prime. That means y prime is 2 over x squared. And next we're gonna integrate to get the y, or y equals the antiderivative of 2 times x to the negative second with respect to x. That gives us y equals negative 2 over x plus another constant of integration, c2. With the initial condition y at 1 equals 4, y at 1 equals 4, we place into the equation to get the c2. Then we get 4 equals negative 2 plus c2, or c2 equals positive 6. That means our solution is y equals negative 2 over x plus 6.